Geometry, Chapter 4, Section 1, Classifying Triangles. So we're going to start out and we have to be able to name and describe triangles in a variety of ways so it's easier to refer to them on the page. And if we can classify them, then we can find out some relationships about specific types of triangles. For example, um, right triangles, one of our options here, if one of the angles is a right angle, and you can see there's one down in the bottom right corner, there's a lot that can tell you about that. Uh, right triangles like this is basically what the entire course of trigonometry is based on. So you have to know right triangles, and there's a lot that right triangles can tell you. Um, we also have obtuse, where it has one obtuse angle in it. The other two angles are going to end up being acute. And equal angular, of course, all three of the angles are the same exact value. And acute triangles, all three of the angles are less than 90. So those are the four classifications when it comes to angles in triangles. So let's go ahead and do a little bit of classifying here. Classify the triangles by angles. Use the best description to classify each triangle. Acute, equal angular, obtuse, or right. So we're looking for specific characteristics of each one of them. In A, I see 70, 40, and 70. All of those are less than 90 degrees. Because all of those are all three of those angles are less than 90 degrees, I call this an acute triangle. On part B, I have 30 and 60, which are both less than 90, so I'm like 2/3 of the way there to an acute. But if you notice that last angle is 90 degrees, and the big distinction between obtuse and right angle triangles is if I have one right angle, it's a right triangle, and I have 90 degrees here, so I call this right. If you had like say 20, 60, and uh, 100, that would be obtuse because you'd have one angle that's bigger than 90. And when you're looking at it with the numbers all spelled out, it's not too difficult, right? Sometimes they are actually going to have you have to solve and figure out the relationships that are here. So, first thing that you have to do on all these kinds of problems, like in example 2, where we're classifying again, so which one of those four is it? We just have to be very careful about making sure we can identify all the angles that they're talking about. And the first step is always make sure you know which triangle there is, because there's actually three triangles in this picture. There's the triangle on the left, the triangle on the right, and then the whole triangle. So, you're going to want to make sure you're looking for the correct one. I'll highlight it in blue here. PQR. So you start at P, go to Q, then go to R, and then it brings you back to P. So that's the triangle I'm looking at. So you can see they kind of threw a red herring out at you by putting a 90-degree symbol down here in the bottom. That's not actually part of my triangle, so I'm not going to be using it at all. So I don't have a right triangle because of that. Let's take a look at the three angles. Angle P is 45. That's acute. Angle R is 31. That is also acute. So far it looks acute, but we've got this big angle up here in the top. And you see how it's these two other smaller angles added together? 45 plus 59, what do those add together to be? Looks like they add together to be 104. That's bigger than 90, right? So this is an obtuse triangle because, and I'm on the explain part of this, angle PQR is 104 degrees. Now notice here I did not say angle Q. I did not say that, because here there are two different angles that are relating with Q as the vertex. So I have to be specific and choose their sides. Thankfully, it's the same sides as the triangle. So I make sure I have PQ and then down to R, PQR. And that gives me this whole angle right here.